Open on extreme close-up of cracked desert earth. Heat shimmer. Then cut to the cool interior of an ancient stone building. Ambient sound. Wind moving through stone. Narrator. There is a structural technology that can cool your home by 15 degrees Fahrenheit in the dead of summer, without a single moving part. No fan. No compressor. No electric bill. It has been used, continuously, for over 3,000 years. And yet, right now, if you tried to build it into a new home in most American cities, you would likely be denied a permit. So what is it? Why does it work? And why? If it's this effective, did the modern building industry decide you weren't allowed to have one? That's exactly what we're going to find out. If you're new here, this channel covers forgotten engineering, lost technologies, and the structural innovations that were quietly left behind. If that's the kind of knowledge you want more of, subscribe before this video ends. It genuinely helps this content reach people. Now, let's follow the air. Every summer, hundreds of millions of households across the United States flip on their air conditioning. The compressors kick on. The meters start spinning. And nobody asks why. But here's the question worth asking. If there is a proven, passive cooling system, one with zero operating cost, zero mechanical failure points, and a track record spanning 3 millennia, why is the default solution a machine that breaks every decade, requires annual service contracts, and adds hundreds of dollars to your utility bill every single summer? The answer isn't engineering. The modern air conditioning system is not superior technology. It is a system built for a market. And that market depends entirely on you needing a machine. The technology we're talking about today doesn't care about markets. It runs on the weight of the atmosphere and the heat of the sun. It is called the solar chimney. And the fact that you've probably never heard of it, in spite of it being one of the most studied, most validated passive cooling systems in architectural history, tells you almost everything you need to know about how the modern building industry actually works. But before we get to the suppression of this technology, we have to understand where it came from. Because the origin story of the solar chimney doesn't begin in a laboratory. It begins in one of the most brutally hot places on Earth, and with architects who had no other choice but to get it right. The year is approximately 1000 BCE. The location, Yazd, a city on the arid central plateau of ancient Persia, modern-day Iran. In summer, the ambient temperature in Yazd regularly exceeds 113 degrees Fahrenheit. There is no shade on the plateau. There is no river. The sun bakes the earth from sunrise to well past dusk. And yet, for 3,000 years, this city has been continuously inhabited. How? Cut to footage or illustration of badger towers rising above ancient rooftops. The answer stands above the rooflines. Tall, narrow masonry towers. Some rising 40 feet into the air, oriented with precision to the sun. These are called badgers, windcatchers, and they are, without question, the world's first solar thermal engines. But calling them windcatchers actually understates what they do. They don't just catch wind. They manufacture airflow, using nothing but the physics of heat and density. Here is how it worked. The stone walls of the tower are thick, dense, high mass. During the day, the sun-exposed face of the tower absorbs enormous quantities of solar radiation. The air trapped inside the shaft heats up. According to the ideal gas law, the same principle that governs every atmospheric phenomenon on Earth, as air heats, its density drops. It becomes lighter than the surrounding air. It rises. And as it exits through vents at the top of the tower, it creates a zone of negative pressure at the base. Nature, as it always does, fills that vacuum. Fresh, cooler air is drawn in from the shaded courtyard at ground level. In many cases, it was first routed through canets, underground water channels, where evaporative cooling dropped its temperature even further before it ever touched a human being. This wasn't decoration. This wasn't tradition. This was precision engineering, built from an intimate understanding of thermodynamics, centuries before thermodynamics had a name. And it spread. By the 19th century, as the British Empire expanded into tropical and subtropical regions, military engineers encountered these systems and immediately recognized their value. The British Medical Journal documented wards in India and East Africa equipped with thermal stacks that showed dramatically lower mortality rates during cholera and influenza outbreaks. Not because of medicine, because of physics. The towers provided a continuous atmospheric flush, removing pathogens, moisture, and stagnant air that mechanical systems simply couldn't replicate. This was the global standard for high-performance climate management for 3,000 years. Then electricity arrived. And everything changed. To understand why a solar chimney outperforms a mechanical cooling system, you have to stop thinking about air and start thinking about pressure. Visual, animated cross-section of a building with a solar chimney. A modern solar chimney is a vertical shaft, typically attached to the south-facing wall of a structure, where it receives maximum solar exposure. It consists of three core components: a high-mass absorber plate, usually a dark-coated metal or masonry surface, a layer of high-transmittance glass positioned in front of it, and a sealed air column between them. Here is the sequence. Solar radiation passes through the glass. It strikes the absorber plate and is converted into long-wave thermal energy, heat. The air inside the column heats rapidly. Per the ideal gas law, as temperature rises, density falls. That superheated air becomes buoyant. It rises fast and exits through exhaust vents at the top of the chimney. That upward movement creates a zone of negative pressure at the base of the chimney. And because the building is sealed except at one intake point, typically a north-facing vent or an underground earth tube, the house is forced to inhale. It draws in fresh, cool air from the lowest, most shaded part of the structure and pulls it up through the living spaces. Now here is the detail that makes this system genuinely extraordinary. The system is self-regulating. The hotter it gets outside, the stronger it runs. On a 100-degree afternoon, when an air conditioning unit is working at maximum capacity, drawing maximum current, the delta T inside the solar chimney is at its peak. The temperature differential between the absorber plate and the ambient air is highest. The pressure differential is largest. The chimney pumps hardest. The machine that brute forces its way through heat. The chimney that runs faster because of it. And in winter? This is where smart design separates itself from simple design. A properly engineered solar chimney includes a bypass damper system. In the heating season, you close the exterior exhaust and open an interior return vent. The rising heated air is no longer vented outside. It is recirculated back into the building's thermal mass. Your cooling system becomes a passive solar heater. No modification, no additional hardware, just a damper. The performance ceiling of this system is determined by two variables: the height of the shaft and the temperature differential. Taller shaft, greater pressure drop, higher air velocity. Think of it as engine displacement. The taller the chimney, the larger the engine. And for those willing to take it one step further, there is a combination that produces what can only be described as a 0-watt air conditioner. You pair the solar chimney with an earth tube. You bury a 100-foot run of 6-inch pipe 6 feet underground, where the soil temperature remains a constant 54 degrees Fahrenheit year-round. The solar chimney provides the suction. It pulls fresh outdoor air through that pipe. By the time the air reaches your living room, it has been geothermally pre-cooled to approximately 70 degrees Fahrenheit. No compressor, no refrigerant, no kilowatt hours. A system that works even during a total grid collapse. This is the point in the story where skeptics want numbers. And the numbers exist. In 1995, researchers at the University of Arizona conducted an extensive field audit of a residential solar chimney installation in the Sonoran Desert, one of the harshest thermal environments in North America. The result: the system maintained an interior temperature of 75 degrees Fahrenheit, while the outdoor temperature sat at 106 degrees. A 17-degree reduction, using no electricity whatsoever. But the thermal performance, as impressive as it is, may not be the most important metric. The Environmental Protection Agency estimates that indoor air in a modern sealed home is routinely 2 to 5 times more polluted than outdoor air. Volatile organic compounds from building materials, carbon dioxide from occupancy, moisture from cooking and respiration. In a modern airtight home with a standard HVAC system, actual fresh air exchange rates fall below 0.5 air changes per hour. A solar chimney provides between 8 and 12 full air changes per hour of 100% fresh, filtered outside air. That distinction matters profoundly. Sick building syndrome, the cluster of symptoms including headaches, respiratory issues, and cognitive impairment associated with modern sealed buildings, is, at its core, a ventilation problem. The solar chimney solves it structurally, permanently, without ongoing cost. A study from the University of Nottingham found that buildings utilizing solar chimneys could reduce their total cooling energy consumption by up to 75%. And on carbon? A standard 3-ton central air conditioning system carries an embodied carbon debt of approximately 25 metric tons of CO2 over its 15-year lifespan, accounting for manufacturing, refrigerant emissions, and operational energy. A solar chimney, built from high-mass masonry, recycled aluminum, and glass, achieves carbon payback in less than 6 months. After that point, its operating emissions are zero. It is, quite literally, a carbon-negative asset. So given that the evidence is this clear, this well-documented, why isn't it everywhere? That question leads us to the most uncomfortable part of this story. Here is where the story takes an unexpected turn. The solar chimney wasn't defeated by better technology. It wasn't abandoned because it stopped working. It was structured out of the market, deliberately, systematically, and profitably. The modern American building industry runs on a model called subcontracting and standardization. A developer builds a thin-walled, minimally insulated structure as quickly and cheaply as possible, and then contracts out to an HVAC company to make it livable. It's a plug-and-play model. No specialized architectural knowledge required. No integration into the building's thermal geometry. A solar chimney disrupts that model fundamentally. It has to be designed into the building from the ground up. It requires an understanding of the building's neutral pressure plane. It requires integrating vertical shafts into the structural frame. It is, in other words, architecture, and architecture costs time. But the regulatory barrier is arguably more damaging than the economic one. The primary governing document for residential construction in the United States is the International Residential Code, written around ASHRA 62.2 ventilation standards. Those standards are written entirely around mechanical systems, systems with horsepower ratings, UL listings, and Energy Star certifications. That a solar chimney is a passive architectural feature. It does not have a model number. It does not have a factory certification. Its performance varies with solar intensity, which means it cannot be input into the standardized compliance spreadsheets that inspectors use. And so, in most jurisdictions, a building inspector will look at your solar chimney, acknowledge that it functions, and then require you to install a mechanical backup system anyway, citing compliance with ventilation code. You are, in effect, forced to buy a machine you don't need to satisfy a regulatory framework that was never designed to accommodate anything else. Then there is the incentive problem. A solar chimney, once built, requires no replacement parts. It generates no service calls. It has no refrigerant to recharge, no filter subscription to sell, no annual maintenance contract to renew. The utility company sees no monthly revenue from it. The HVAC contractor sees no repeat business from it. We have built an economy around mechanical failure, and the solar chimney, by its nature, refuses to participate. There is a word for what has happened here. Not a conspiracy, a succession of failure. A system in which you are sold a house designed to fail thermally, then sold a machine designed to fail mechanically, at regular, predictable intervals, for the rest of the time you live there. The chimney breaks that cycle. And that is precisely why it was never put in your building code. Oh, where does this leave you in 2025? The honest answer is this. The solar chimney is not a solution for every building or every climate. In the Pacific Northwest, where overcast skies reduce solar gain for months at a time, a standalone passive system needs supplemental design support. In humid subtropical climates, the system needs to be paired with dehumidification strategy. Cold climate installations require careful damper management to prevent heat loss in winter. But for anyone in a hot, dry, or mixed climate, the American Southwest, the Mediterranean, South Asia, the Middle East, Sub-Saharan Africa, the solar chimney is not a supplement to mechanical cooling. It is a replacement. For existing homeowners, the most accessible entry point is a wall-mounted solar chimney, an insulated collector box attached to a south-facing exterior wall, connected to the building interior through two 6-inch vents, one at floor level, one at ceiling level. Built with UV-stabilized polycarbonate, selective surface absorber plate, and high-temperature silicone sealing, a DIY build for a 500 square foot space costs between $300 and $500. That is a one-time capital expenditure with no recurring costs, ever. For new construction, the calculus shifts even more dramatically in favor of passive design. A properly designed building, with integrated vertical thermal shafts 20 to 30 feet in height, a spectrally selective absorber surface, low iron glazing, and a geothermal earth tube intake, can provide complete summer cooling with zero mechanical assistance. The comparison to conventional HVAC is not marginal. A 3-ton AC system costs $5,000 to install, $200 per year to service, and adds several $100s per month to your utility bill. It will need full replacement within 15 years. The solar chimney costs less to build, costs nothing to operate, and will outlast the building it serves. The people who benefit most from this technology right now are owner-builders doing custom construction in high sun climates, homesteaders and off-grid builders seeking genuine energy independence, anyone in a region with unreliable grid power, and anyone willing to challenge the regulatory default with a competent architect and a determined building inspector, the people for whom it is a partial solution, anyone in a heavily overcast climate, or anyone unwilling to accept performance variability on low solar days, and the people for whom it is simply not yet accessible, those subject to building codes and HOA regulations that effectively prohibit passive architectural systems through bureaucratic indifference. That last group is the largest, and changing it requires making the conversation louder. So let's return to the question we opened with. If this technology works, if the physics are sound, if the research is clear, if 3,000 years of continuous use in some of the harshest climates on Earth have validated its performance, why don't you have one? Because working and profitable are not the same thing. The solar chimney does not generate a revenue stream for the utility company. It does not generate a service call for the HVAC technician. It does not generate a filter subscription or a refrigerant recharge or a replacement unit every 15 years. It is a permanent structural organ of the building, built once, running forever. And in an economy that depends on recurring mechanical failure, permanently functioning things are a problem. What the ancient Persian engineers understood, and what 3 millennia of field testing has confirmed, is that the most sophisticated solution to a thermal problem is not a machine. It is geometry. It is material science. It is an elegant, permanent exploitation of the laws of the atmosphere. The machine is the primitive solution. High energy, high cost, high entropy. The chimney is the sophisticated one, silent, permanent, and completely indifferent to your utility bill. The technology hasn't disappeared because it failed. It has been crowded out because it succeeded too completely. And knowing that changes the question. It's no longer, why don't we use this? It's, what would it take to bring it back?